So now that we have completed going through the initial training instructions that we need to follow in a typical WebEx-based program, now we are ready to continue with our actual discussions on our topic of our training that will be on Java-based microservices. But before I introduce you to the agenda of our training, and then we can go ahead module by module as per our plan, as per our agenda. Please note there is a mandatory prerequisite knowledge that you need to have before attending this training program. Yeah. So these are the mandatory prerequisites. Before you attend Java Microservices training, the mandatory prerequisites is you should be aware of Spring Framework. Plus, you should also be aware of Java-based RESTful web services. So you should have good working knowledge on each of these skills, Spring Framework and Java-based RESTful web services. Yeah. Another optional or recommended prerequisite is you should already be aware of Spring Boot. That is the best, or that is the recommended prerequisites. But even if you don't have knowledge of Spring Boot, anyway, I'm going to give you an introduction to Spring Boot on day 2, that is tomorrow. So that should be okay. But you need to have good working knowledge on Spring Framework and Java-based RESTful web services. Yeah. Anybody who do not have these mandatory prerequisites, this training is not for you. Please note that. Yeah. Don't get offended because we are expecting you to know the mandatory prerequisites. It's mandatory because only when you know about these, understanding of microservices will be better. Yeah. So I want to know from each one of you, are you all comfortable with the mandatory prerequisites, please? I can see a lot of yes coming in. I can also see messages telling I don't have any prerequisite knowledge. Yeah. Please note, this will be a development or implementation based training program. If you do not have the mandatory prerequisites, I am requesting you to log off. This training is not for you. Yeah. So participants without these mandatory prerequisites, at least the mandatory prerequisites, yeah, this training is not for you. Yeah, is not for you. Please gain the prerequisite knowledge and then you can come back to this training program. Yeah. So I'm going to give you a minute. People who do not have these mandatory prerequisites, please note this training is not for you. Okay, so you can log off. I'm going to give you 1 minute for people to log off, please. People who do not have these prerequisites. Ah, great. So let me keep this in case during tea time also, I think we can demonstrate this and then leave. Ah, great. So I'm assuming that people who are with me have these prerequisites, right? And I also wanted to know, though Spring Boot is an optional or kind of recommended prerequisites, I just want to know from all of you, are you aware of Spring Boot? Can you give me an update? I'm checking with the optional prerequisites, please, all of you. I can see almost all of them were yes. Okay, that's nice. So if all of you are having Spring Boot knowledge, at least the broader knowledge of Spring Boot, tomorrow when I give you an introduction, we can probably restrict ourselves to a very quick introduction and then we can move on. Yeah, that's why I'm asking. Okay, great. Thanks for the confirmation, guys, all of you. I guess it's time for us to continue with our deliverables. Yeah. So starting today, the next 7 sessions, we will be looking at this main topic of discussion on microservices in Java. So broadly, these are the topics that we have planned for our discussion, please. Like any other training program, the first module will be an introduction to the skill that we are going to learn. So I will be introducing you to microservices. Me and you have been Java developers and we have created a lot of different types of apps till now, right? And we have used many different architectural styles to build them. But what is microservice? What advantages does it provide us? Why is it necessary for me and you to pick up the skill on microservice? That is something that we will discuss in the first module. So the first module will be an introduction to microservices. Post that, because we will be using Spring Boot framework to build and work with microservices, it is important to get an introduction to Spring Boot. So though Spring Boot is optional or recommended prerequisite, in case majority of us have Spring Boot knowledge, I can quickly give you an overview of it and then we can move on to the next few topics. Yep. So I will be moving on to the microservices related topics. Before that, I will also give you an introduction to what is Netflix OSS and what is Spring Cloud. So we'll be working and using many such projects of Netflix OSS and Spring Cloud during our training. So I'll introduce you to them. And when we start working with microservices, apart from just creating microservices and ensuring that we are able to communicate between these microservices, we will also require help of several peripheral projects, which ideally help us to manage this distributed setup that we might build using microservices architecture. So under such projects, we will be learning and working with a registry service project called Eureka. We'll also be implementing and using a client-side load balancer. For this, we'll be using a product called Spring Cloud Load Balancer. Plus, I'll also be introducing you to the concept of circuit breakers and why circuit breakers might be needed. And under that discussion, we will be working with one circuit breaker project from Spring Cloud called Resilience 4G. So this is what we will be planning throughout our training. Yeah. Please note, at this juncture itself, I am very clearly mentioning this training will expect you to do labs. There will be hands-on labs that each one of you will have to work on and you will have to submit it to me for review. Please do not give reasons that you are in a billable project, you don't get time, etc. All of us have other tasks to do at Wipro. But in case you are planning to attend this training program, it is mandatory that all of you have to work on hands-on. So please decide now itself. Only if you have or can take up time for doing your labs, I recommend you to attend this training program. People who do not have time, who cannot take out time to do the labs, you are not welcome to a training, because just attending a training is not the fun of it, you know. Only when you apply your knowledge on a given scenario, your learning becomes complete. So hands-on is mandatory for this training. So please decide based on your current tasks that you have at work. You will have to take out time on every day to complete your labs. Yeah. Only those people should continue the training. Are you all with me? Yeah. How many of you are ready to do all the labs as prescribed by the trainer, please? Yes, great. So anyway, I will be following up with each one of you. I'll give you all the details of what labs you have to do and stuff like that as and when we proceed. Don't worry. Yeah. Great. So with this intro, I guess it's time for us to start off with our first module. Shall we? Great. So, there is one more important announcement to make. Any doubts you have? I'm seeing that at present there are 113 participants who have joined this training program, and many of them are still joining in. So, addressing queries and clarifications of many participants during the training program might not be feasible, though I will be opening up the forum for question and answer for a couple of maybe for maximum 15 to 20 minutes on a daily basis. In case we have any doubts or clarifications, I think we will have to use the MS Teams rigorously for getting the clarifications done. Yeah. So I will be sharing the details of the MS team in some time. I want all of you to join in. And in case you have any clarifications, etc., on whatever we have covered and we were unable to answer those questions during the training period, we can always take those questions. Okay. So please always be equipped with a paper and a pencil so that you jot down the doubts that you might have during our discussion. And when I open the forum for Q&A, we can always take your questions. And in case your questions did not get answered during that period of Q&A, we will always address it in the question and answer session that we can always do in MS Teams. Is that okay, all of you? Yes. Okay, great. So come, let's start off with our first module, Introduction to Microservices. So let us go through the first module. Let me complete the first module. First module is only a conceptual module. You will not have any labs per se, but understanding the concepts is very, very important. Yeah. Do you all agree, guys? Yeah. For example, today we are doing a microservices training, right? In the first 10 minutes of our training, can I say that, hey, come, let's implement a microservices program. Can I do that? Not really, right? I'm sure like each one of you agree that we need to understand the core concepts of the skill that we are learning. And once you understand the core concepts, implementing is just a task, you know, it's just an easy task to do later. Okay. So keeping that in mind, please remember, as per the instructions that I've already shown you, as soon as we assembled for this training, that on the last day of the training, you will also be expected to take up and clear a quick assessment. So the quick assessment will have questions from concepts, questions from practicals and all that. So only if you are attentive during the training program, only if you take out time out of your busy schedules and do some hands-on, only then it will be easy for you to clear the quick assessment. Yeah. So remember that. With that, I guess it's time to start off with our first module. Shall we? Yes. I will be sharing all the PPTs, all the programs, all that once the training is over. So don't worry. You need not make elaborate notes. Anyway, you will get this PPT from me and demo programs, everything you'll get it from me. Don't worry. Yeah. But of course, in case you want to make some notes, I'm not stopping you from doing that. Please go ahead and make some notes quickly if possible. So a hearty welcome again to the first module of microservices. As per our agenda, the first module will introduce you to the concept of microservices. Yeah. So let me introduce you to the objectives of this module, please, all of you. In this module, we will discuss the different kinds of applications that me and you have been creating till now as developers. And we will also get intro to web services also. Of course, web services is a mandatory prerequisite, but we will again reiterate the points that we are aware of my web services, because you know what? Microservices are a natural extension of web services. So if you know if you know web services, and if you know how web services work, understanding microservices becomes very easy, because microservices is a natural extension of web services. So I'll introduce you to the different kinds of applications that we've been creating. Plus, post that, I will introduce you to the microservice architecture. We will also analyze the important attributes of microservices. We will also talk a little about the thought behind this new architectural style called microservices. Of course, microservices, like any other architectural style, has its own set of advantages and disadvantages. So we will talk about advantages and disadvantages of microservices. Post that, I will also introduce you to what are some of the microservices frameworks that we could use if you want to start implementing microservices based distributed applications. So these are the objectives that we will try to cover in our first introductory module. Yeah. So me and you as a developer, we have been creating different varieties of programs, right? Though the microservices as a concept is the same, irrespective of which programming language you use to implement, our training program will focus from Java's perspective. So me and you as a Java developer, we have been creating different kinds of applications, right? So one variety of application that we have created is local applications. So the regular console-based applications that we create using core Java facilities is a local application, right? So talking a little about local applications. Local applications are applications that run or that get installed on the local machine. So they are locally available and they're locally running on your desktop or on your PC. So they are basically called as console-based applications. Yeah. Now, if you look at typical core Java-based console-based applications that you run, they have their own set of advantages and disadvantages, right? So the advantages of such console-based local applications are they're very rich in the way they look and behave. They're very fast because the application is running on your local machine. So it takes advantages of the local resources available. So they are quick, the UI is beautiful, and the performance is great, right? But the disadvantage of a local application is, as the name itself suggests, the disadvantage is in terms of accessibility, right? So for example, a local application is available locally. So if I have PC at office and assume on my PC, I have installed a local application. That's a local application and I can use it at my office because it is installed only on my PC. Now tomorrow, assume I work from home. But tomorrow, when I'm sitting at home, I can't access that local app because the local application was installed only on my PC. So if I have to use that app, I have to be present in my office because my PC is at office, isn't it? Yeah. So that's a local application. Now, slowly, we started also building remote applications. So as the name itself suggests, in a remote application, The application or the services are remotely available. They are available on a particular network address, and remotely it can be accessed, right? So there are different yesteryear technologies that we could use to create such kind of remote applications. Yeah. So one such yesteryear technology that comes from Java is called as Java RMI. Yeah. RMI stands for remote method invocation. Yeah. Have you guys worked with Java RMI, guys? It's not mandatory, but I'm just asking you. Yeah. Okay, I can see a lot of no's, but a couple of yes. That's okay. So using Java RMI, which is a remote method invocation API, we could create two components, a server component and a client component. Now internally, as the name itself suggests, server component is available and running on a remote location, remote server, and it is providing us some services. And using the RMI client, I can remotely consume these services. So if I have to use the Java RMI API and build such remote applications, we were expected to build the RMI server and RMI client. And internally, we have to implement stub, skeleton, and proxy. And using stub, skeleton, and proxy kind of concepts, the client was able to interact with the server and make use of those services. Yeah. Very similar to Java RMI, Microsoft also had its own technology called DCOM. Microsoft DCOM it was called. Plus there was one more technology available called Corva. Yeah, all these were technologies that were allowing us to build remote applications. Yeah. Now talking about another kind of application, we started creating web applications, right? So because we are from Java, using servlets and JSP based technologies, we could create web applications, right? Now, what do you mean by a web application? Web applications are applications available on the web or on the internet. So once we create a web application and once we deploy it on the web server, anybody who has access to the URL of that application can access it, isn't it? Yeah, that's something called as a web application, and the basic technology that we have used to create such web applications is servlets and JSP, isn't it? Yeah, I'm asking a very stupid question, but still, I'm sure each one of us here have knowledge of servlets and JSP, and using servlets and JSP, we have built web applications, isn't it? Yes, right? And of course, instead of using plain simple servlets and JSP based technologies, of course, we might have also used certain frameworks to create web applications, isn't it? Yeah. For example, there is a framework available called struts. Using struts, we were able to create a web application much more easily. Yeah. Apart from struts, of course, you can use Spring framework also to create web applications. Yeah, which are based on the MVC design pattern, isn't it? Yeah. So, of course, whether you use specific frameworks or you use the base technology of servlets and JSP, we were able to create web applications and make use of all of them, isn't it? Yeah. So, do you all agree that if you look at our history timeline, these are the broader kinds of technologies or the broader kind of applications that we have been creating, guys? Yes, right? Now, going one step further, okay, apart from all these, we might have already worked with a architectural style called web services, right? Now, what is a web service? Web service is one implementation of the service-oriented architecture. Yeah, many of us might have heard about SOA or SOA, however you might want to pronounce it. Service-oriented architecture was an architectural style which proposed a style where whenever you are creating your app and its functionalities can be treated as services. And once the services is up and running, anybody should be able to use those services using some standard mechanisms and thereby reduce the dependency which is either based on protocols or which is based on specific programming languages, isn't it? Yeah. So taking one step further, the implementation of service-oriented architecture was done through web services. We are all aware of web services. If we need to talk a little about web services, can I say that web services are nothing but they are functionalities that provide certain services on a particular network address, right? So whenever you think of a web service, think of a web service as a functionality available on a particular network address. And once the web service is available, a potential client can consume it over the web, right? Or over the network, either using standard protocols or techniques or using some specific protocols and techniques. The idea of web service is to provide you specific advantages. So two broader advantages you get when you work with web services. One is web services helps us to create an interoperable application. Plus, it also proposes or it provides me an opportunity to create a loosely coupled application, right? Now, what do you mean by interoperable? I'm sure when we have worked with web services, we are aware that even in web services, when we create, there are two parties involved, right? The provider and the consumer, right? You can call it as a server and a client, but you have two parties, right? The provider provides some services and the consumer, as the name itself suggests, consumes these services, isn't it? Yeah. And if you look at web services as a technology, there are broadly two architectural styles or two technologies you can use to create and consume web services. Yeah. One is either you can use XML based technologies, which involves a protocol called SOAP. It involves a technology called WSDL, UDDI, etc. Using XML based technologies, you can create these web services and you can ensure that they talk to each other, right? Apart from XML, another architectural style for building your web services is an architectural style called REST, isn't it? Team, are you all with me? Yes, right? And please remember, RESTful web service is a mandatory prerequisite for our training. So I'm sure all of you have worked extensively on web services and you have built RESTful web services, isn't it? Yeah. Now I'm sure like you might have already be aware. There are two standard protocols and techniques that are typically used to create and work with web services. One is service-oriented architecture-based, XML-based technologies. And the other one is REST-based technologies. Yeah. So talking a little about REST-based, can you tell me what is the full form of REST, all of you? What is the full form of REST? Correct. Representational state transfer, right? REST stands for representational state transfer. Yeah. And can I say REST is a architectural style to implement web services? Can I say this, guys? Yes, right? Even in REST, what are some of the salient features of REST? Yeah? REST is based on, okay, REST is based on regular web standards and HTTP protocol, isn't it? Yeah. Are you all comfortable with the third point? Yeah. REST is based on web standards and HTTP protocol, right? And in REST, as per REST architecture, yeah, as per REST architecture, everything is a resource, isn't it? Yeah. And the resource can be accessed by a URI or a URL, isn't it? Yeah, as per REST-based architecture, everything is a resource, and once the resource is available on the net, you can access it by using a URI or a URL, is it? Yeah. And once you can access it, REST also supports standard HTTP methods. So you can perform standard HTTP operations on your resources. Okay. So what are the standard HTTP methods you can use on the REST resources, guys? What are they? Correct. Don't say CRUD. CRUD means it talks more on the database perspective. I want you to tell me what are the HTTP methods. Yeah. Correct. The HTTP methods are post, yeah, get, put, and delete. Isn't it? Yeah. Delete. These are the standard methods that we use. Are you all comfortable with this, guys? Yes, you should be, in fact, isn't it? Yeah. Because as I told you, we are going to discuss about microservices, and you know what? Microservices are natural extension of web services. Specifically, it is a natural extension of RESTful web services. Okay. Now, so if you want to create RESTful web services, there is an API that we use, right? Which is the Java API, which provides the basic foundational support for me and you to create and consume RESTful web services, guys, which is the Java API that provides us the basic foundational support for creating and consuming RESTful web services. Correct. JAX RS, right? JAX RS. And JAX RS is just a broader specification. It just puts down rules and regulations as to how the server has to get created, how the client has to get created, internally how they should talk, all that, right? It's a broader specification. That's it. But JAX RS API is implemented by several vendors, right? That is called as reference implementations. Yeah, there are several JAX RS reference implementations. Me and you as a developer, whenever we want to create a RESTful web service, we should use one of those reference implementations, right? So can you tell me some of the reference implementations of JAX RS that you guys are aware of? Correct. One popularly used open source reference implementation is Jersey. Yeah. And of course, apart from Jersey, you also have something called REST Easy. Plus, yes, correct. Okay. You also have Spring REST. Spring REST also is a reference implementation of JAX RS. So you could have used any one of these. Funda is the same. Slight changes in the annotation and all that, but the fundamental idea remains the same. Yeah. Now, of course, if we are using Spring Boot, we will be using Spring Boot framework later to build microservices. Spring Boot is based on Spring REST. So internally, it uses Spring REST kind of reference implementation while working with JAX RS. Yeah. Team, are you all with me? Yeah. Purposely, I did this review because understanding RESTful web services is mandatory before we understand our microservices, because microservices is a natural extension of RESTful web services. Okay, remember these points, please. Now that we have discussed only about the kinds of application that we have been creating till now, and we have also elaborated a little on web services per se. Now we will look at what do you mean by microservices. Yeah, have a look at this, please, all of you. Till now, I have been harping on this fact, right? Look at the first point. Microservices is a new architectural style. Yeah, it is a natural extension and the most latest architectural style to build distributed applications. So if your intention is to build a distributed application, then microservices is one of the natural extension of web services, and it is the most latest architectural style to build our distributed applications. Look at the second point. very similar to web services. Even in microservices are nothing but functionalities that are available on the internet or available on a network address, and they can communicate with each other over the network in order to accomplish a specified goal. So very similar even in microservices. Microservices also very similar to web service are nothing but functionalities available on a particular network address. It will be providing you some kind of service, and when there are multiple services, these services can talk to each other, thereby providing the expected functionalities for an end user. Yeah. Before I proceed any further, I also want you to look at this word called microservice and look at this word called micro. Service, we know service means a functionality. But what do you think is the English meaning of this word called micro? Guys, what do you think is the English meaning of this word called micro? Correct. Micro means small. Yeah, not very small. Okay, don't say small, don't say very small or smallest. I will come to that later. For now, I want you to remember that micro means small. Okay, so obviously microservice means small service. Yeah, and whether we like it or not, look at the third point. Microservices architectural style is kind of becoming a standard for building continuously deployed systems. And especially nowadays, where the de facto infrastructure for majority of our clients is cloud, and in your projects, you are using some kind of continuous deployment and continuous integration kind of tools to ensure that your functionalities are easily and quickly delivered to the client, and you are also using cloud as the default or de facto infrastructure. Microservice architecture is kind of becoming a de facto standard while building such distributed apps. So whether we like it or not, microservices architecture is here to stay. And me and you as a developer, only way that we can do better is to pick up this microservice architecture and understand how to use this architecture to build our distributed apps. Are you all with me, guys? Yes. So based on our discussion, broader discussion till now, look at some points below, please. These are some of the points that you have to remember about microservice. First point to remember always about microservice is microservice is small. Yeah, that's the first point. But why is it small? Look at the second point, which is a connected point. Microservice is small because a microservice addresses a specific concern. To be very precise, whenever we build microservices based architecture based distributed app, one microservice addresses a single concern. So it is specific. Why is it specific? Because it addresses a single concern. That is why it becomes small. And because it is addressing only a single concern, it is lightweight. Yeah, it is lightweight. It need not do some hundreds and thousands of things because it is addressing only one single concern, right? That is why it becomes lightweight. And of course, as a natural extension of RESTful web services, microservice functionality uses standard protocols and techniques. So, as a natural extension of RESTful web services, which protocol does a RESTful web service use, guys? RESTful web services are based on web standards, and they're based on what protocol? The HTTP protocol, right? So very similarly, even a microservice, when you build a microservice, if these microservices talk to each other and use standard protocols and techniques. So the very widely used standard protocol on the internet is HTTP, and as per REST also it is based on HTTP. Yeah, just remember all these points about microservice. Yep. Okay. Before I talk about the microservices perspective, okay, or before I talk about the important attributes, this is a very important slide where very broadly on a very high level, it is giving you a perspective of microservices. Yeah. Now you can see here, this picture has two parts. This is a depiction of how a monolithic app looks, and this is how a microservices based app looks. Yeah. First, let us discuss about a traditional app that we usually build, a non-distributed app, which is a monolithic app. Yeah. So the first picture here you see is a monolithic app with a single database usually. Yeah. So if you look at this picture, you can see here that there is, I'm going to ask you a very stupid question, but still I'm going to ask you. In a monolithic app, mono, okay, monolithic is based on the word called mono. So in a monolithic app, can you tell me how many apps are there? I told you it's a stupid question, but still, okay. Yes, that's only one app, right? So you can see here, this entire thing is only one app. Okay, there's only one app, and inside this one single app, all the functionalities are implemented, right? So there's all the, how many ever functionalities are required to be implemented, all the functionalities are implemented in one single app. And typically a monolithic will also have one single database. Of course, inside this database, it might have multiple tables, which is a structure made up of rows and columns. And in case you're using a relational database management system, obviously the table is the base component of a relational database management system. And the data will be persisted in the table. And whenever it's required, it will be pulled from this table. So typically, this is how a monolithic app looks. Are you all with me? Yeah. One app implementing entire functionalities, all the functionalities, and typically one database. That's how the monolithic app looks. Yep. But look at the perspective of a microservice based app. I want you to carefully look at this picture, then we'll have a discussion. Yep. Go through the picture here, please. I'm sure you will get a fair idea. So in this example, if you are looking at the microservice based architecture, can you tell me in this example, how many applications do you have? Can you be precise? Yeah, in this example, yes, we have 4 applications. So this is one app, this is another app, this is another app, and this is another app. So you have 4 apps. And let us analyze the app 1. Look at the app 1. Are you able to make out that the first app, can you look at this and tell me how many concerns or how many functionalities is it addressing? Only one concern or one functionality it is addressing. Okay, one concern it is addressing. And to address and handle only that concern or that functionality, are you also able to make out that it is having its own database that might be required to address and take care of that functionality? Yeah. So one microservice is a full-fledged app with its own, and it's not really to address one functionality. It is not dependent on any other. It is one single unit to address a particular functionality, right? So the app will address one single functionality. To address one single functionality, whatever are the data requirements and persistence requirements, that also is handled by its own database. Are you able to make out? Yeah. So a microservice is a single unit of work. You can see in the picture itself, it's a single unit of work addressing a single concern, right? Very similar on the same lines. is the second microservice also. Yeah. Do you see anything different in microservice 3 and 4 compared to the other two? Carefully look at the picture, you will get a hint. Yeah. Yes, you can see that microservice 3 and microservice 4 seeming to be using a single database, right? They are kind of using the single database. But you know what? Though this is possible, highly recommended that in a microservice architecture, what is the definition of a microservice? How many concerns it should address? One single concern. And to address that single concern, it should not be dependent on any other thing. But here, when you are designing and developing your microservice based architecture, where microservice 3 and 4 are interacting with the same database, don't you think so? There is a kind of dependency here. Yeah. Assuming that microservice 4 is kind of, kind of interacting with the database and performing some kind of write operation. Meanwhile, during the same time, the microservice 3 has to read the data. But due to locking issues, the data is locked and the microservice 3 is unable to read the data. This is not what is expected. So in a microservice architecture, it is highly recommended that every microservice has the individual capability to address its own concern. Yeah. So though you can design like this, highly not recommended to design it like this. Are you all with me? Yeah. As far as possible, design your microservice as one single unit to handle its own concern. Yeah. Remember this. But roughly, I'm showing you the architecture or how the perspective is. Team, are you all with me, please? So before we move further, to understand this entire thing well, let us take an example of a e-retail app. Yeah, a e-retail app, anything. For example, Flipkart or Amazon Prime, anything, any retail app that you think of. Okay. So, of course, it's not mandatory that it has to be implemented in microservices based architecture. Of course, it can be designed and developed as a monolithic, right? So in a monolithic, what happens is, assume that this is my e-retail app. Okay, assume this is my e-retail app. And in my e-retail app, if I was implementing it as a monolithic app, in a monolithic app, there will be only one app, right? This is one single app that I have. So this is my e-retail app. And because there's only one single app, obviously, all the functionality of a e-retail app will be handled by one single app, right? So broadly, let us take some functionality. Yeah? So I will take a functionality of registration and login. Think of any e-retail app. Yeah. Registration and login, that is one broader concern. Yeah. Then you have a shopping cart. Yeah. You have a shopping cart. Then you have product management, right? There you have a product management. Plus you have a payment. Yeah. Then you have shipping. Yeah. Right. You have shipping. Plus you have feedback. Okay. Feedback mechanism. And plus you have maybe some kind of reporting, whatever, right? All these are functionalities, and all these functionalities are implemented in one single app. So obviously you will have one single code base, yeah, and everything you will put in one single app. And of course, you might have, typically in a monolithic app, you will have one single database which caters to the persistence requirements. Are you all with me, guys? This is a typical monolithic app. Yeah, it's a typical monolithic app. But if the same app is getting designed as a microservice based app, So if it is getting architected and designed as a microservice based app, if you look at the salient features of microservice is small. Why is it small? Because it addresses a single concern and it is lightweight. Plus, if multiple microservices wants to talk to each other, of course, they can do it using standard protocols and techniques. That's the whole idea, right? So in a microservice-based architecture, you will have one microservice which is handling registration and login. So this is one microservice, right? And another microservice will handle the shopping cart, right? Where the end user can come and shop and search for the products. There's another microservice for managing the products. There is another microservice for payment. Likewise. Yeah. Guys, are you all with me? Yeah. Likewise and so forth. All these will become different microservices. Yeah. But see, from an end user, think from the perspective of an end user. The end user, for him, whether you are internally developing it as a microservice or a monolithic app, it does not matter. It is none of his concern, isn't it? Yeah. For the end user, why the end user is here? He or she wants to shop, right? So assume when the user wants to shop, first maybe they will register and log in. After registering and login, they have to be taken to the shopping cart or the products. And from there, it might interact with the products. Then after shopping, they might do a payment. And after payment, they might provide all the shipping details. And optionally, they might give a feedback, whatever, right? In this example, are you able to make out that these individual microservices have to talk to each other to address a particular functionality for an end client, isn't it? Are you able to make out? Yes. So one microservice has to talk to another microservice. Maybe this microservice also will talk to the other. So intercommunication between the microservices are needed. And of course, they will talk to each other, get the functionality executed, all that. And finally, the result will go back to the user. Yeah. So this is the broader perspective of how a monolithic app looks and how a microservices based app might look. Are you all with me? Yeah. Each microservice is an individual app. Yeah, it's an individual app. Remember this. Now, based on that, keep track of that example because for our further discussion, we can use that example. Yeah. Now I'm talking about some important attributes, yeah, about your microservice. Yeah. These are the important attributes of your microservice. So based on our previous discussion, and I also want you to remember that e-retail app, look at these important attributes of a microservice. Whenever we are designing and architecting and implementing a microservice-based app, please remember that microservices are organized around concerns about the broader functionalities that your app should provide. So we took that example of a e-retail app, right? What were certain broader concern? Concern is nothing but a functionality. Yeah. To implement that, you might write one function or multiple function, does not matter. But they are organized around concerns. So one microservice is handling registration and login requirements. One microservice is handling the payment requirements or the payment functionality. One microservice is handling the product management, right? So you can see that microservices are organized around concerns. Yeah, isn't it? Yeah. And the second important attribute of a microservice is it is easy to replace. I want you to quickly remember that e-retail app example that I just gave you. Assume at present we have designed a microservice based app where the payment gateway or the payment is linked with a third-party payment gateway, and we are using a third-party payment gateway and other logic there. But after a few months, assume we change the third-party vendor. We are now going ahead and using a different vendor. So payment and other details will change. But whenever I want, so what I want to do is, I want to replace that entire payment and plug in another third-party payment piece there. Is it easy for us to do without affecting the other functionalities? Absolutely yes. Because each function, each microservice is addressing its own functionality. So it becomes easier to replace, isn't it? Yeah, that's the second point. Connected to that is the third point. It is of course also easy to change, and whatever changes you do, the changes will be isolated, right? For example, assume you are adding some extra dashboard and some extra reporting options to the reporting microservice. Yeah, I repeat, assume you are planning to add additional dashboard functionalities and additional report options for the reporting microservice. So some changes you are doing for the reporting microservice. So when you are doing some changes to the reporting microservice, should your e-retail app be down? Should you keep your e-retail app down? Not really. Rest of the functionalities are beautifully working. All the others are beautifully working. Live it is running. You are only tinkering and making changes to the reporting, isn't it? So changes are isolated because you have divided the microservice based on concerns. So obviously, if you have done a good job, changes that you're doing to one should not affect the other, isn't it? Yeah. So changes are isolated, isn't it? Yeah. And the next one is very important to think. They belong to one application only. See, understanding this point is important because you remember that picture of e-retail app. We had created 6 to 7 microservices, each microservice handling a particular concern, right? Registration and login, shopping cart, payment, blah, 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 all these. But did you realize that each of these applications broadly belong to one application, which is the e-retail app? Yeah. Why do you have this microservice called register and login? What is it handling? What concern is it handling? It is handling the registration and login part of the e-retail app. What is this payment microservice doing? Payment is handling the payment of this e-retail app. So though these are individual microservices, all of them logically belong to the same app, which is e-retail app in my case, isn't it? Yeah. So remember that. Plus, when you work with microservices, the architectural style is more horizontal than vertical. Now, what is this difference? Think of a typical web service architecture, guys. For once now, let us think of a web service architecture. In a web service architecture, which is a service-oriented architecture-based implementation, there are two parties, right? A provider and a consumer, right? As the name itself suggests, what is the job of the provider? The job of the provider is to provide the functionalities. And what is the job of the consumer? Is to consume these functionalities, isn't it? Yeah. Can the roles be interchanged, guys? In this example, can the roles be interchanged? No. Provider's job is to provide the service and consumer's job is to consume the service, right? That is why the interaction is more vertical, right? You see, the interaction is vertical. One is providing, the other one is consuming, isn't it? Yeah. But in a microservice, it's more horizontal because they all work in a sibling mode. Yeah. Yes, each one of them are providing some kind of service, but this microservice can talk to this. So when this is talking to this might be the provider and this might be the consumer, right? But sometime maybe this microservice might want to access something here. So this will act as the provider and this will act as the consumer. So there is no hard and fast rule that one party will always be the provider and one party will always be the consumer. Not really. It is a horizontal kind of style where depending on the functionalities, each microservice can behave as a client or it can provide the service to others. So that is why you can see that this architectural style is more horizontal and web services is more vertical style. Team, are you all with me? Yes. And look at the last attribute. Last attribute, in fact, is the most important attribute. Yeah. Though it's not mandatory for you guys to know. How many of you have knowledge on cloud? How many of you work with cloud? Either infrastructure as a service, or you might also be using both infrastructure as a service and platform as a service, and you push your app onto the cloud. It's not mandatory for you to know, but at least the broader idea you might have, isn't it? Yeah. Now, keeping in mind this, look at the last point. Scaling individual functionalities is possible. What do you mean by scaling? Yeah. Scaling is one mechanism of improving the app's capability in handling the number of requests. Yeah. Now, for example, assume we will take an example of a e-retail app like Flipkart. Okay. Assume I take a e-retail app called Flipkart. Now, Flipkart has these sale days, right? They have a lot of these campaigns that they run, and they have this. I thoroughly always get confused with these names, but there is something called Big Indian or the Great Indian Festival or something like that, right? They run a huge big campaign. Yeah. Now, and during that campaign of 1 week, usually during Indian holiday and festival seasons, they give lot of discounts and all such things. So I want you to remember one such thing for Flipkart. Okay. During that Great Indian Sale Week, do you think there will be more footfall? Do you think more people will come to do online shopping? Yes, right? Including many of us also. We keep waiting, right? Assume I want to buy some product and I know that, okay, there'll be a lot of these discounts during this time. So I usually wait and buy, right? Now, why I've taken this example is, do you agree that compared to the regular days and those kind of sale days, do you think more amount of people or more number of people come in? Yes, right? So if you agree with that, don't you think so your Flipkart systems should also be capable of catering and addressing the more number of users on those days? Yes, right. Now, how do you, as Flipkart, how can I ensure that your app is scalable and a more number of users it's able to cater to? There are broader mechanisms that you can use. One is called as vertical scaling. The other one is called as horizontal scaling, right? Now, vertical scaling is you might have only one instance of your app, but you might increase its capability. For example, when I say increase capability, you might increase capability, only one instance you might have, but you might increase its capability in terms of the CPU or in terms of the memory, okay, all that. So this is called as vertical scaling. So you will still have only one instance, but that one instance you will increase the capability of it, either the CPU capability or memory, etc. This is called vertical scaling. Another recommended way is called horizontal scaling. Yeah? Horizontal scaling is when instead of running only one instance of your app, what you do is you run multiple instances of the same app so that it can handle multiple simultaneous requests coming in, isn't it? Yeah. This is called as horizontal scaling. Are you all with me? Yeah. We are not getting into nitty-gritties of cloud. Okay, that is not what we are here for. Yeah. Idea here is to tell you that broadly there are vertical scaling, horizontal scaling, and everything you can set up. Yeah. Now, idea is when you are scaling, okay, when you're scaling, look at our, or I want you to, okay, on sale day, okay, on this sale week, okay, in this sale week, which microservices might have more traffic? I'll give you two. You tell me out of these two, which one will have more traffic? One is the payment microservice. The other one is feedback microservice. Okay, there are two microservices one I'm taking as an example. One is the payment microservice. The other one is feedback microservice. So both these, compare both of them and tell me which one will have more traffic. Correct, payment. Yeah, some traffic might still go to feedback, but people will not wait for a sale week to only go and give a feedback. Okay, usually they want to buy products and obviously they are doing payments, etc. Right. Now, idea is, if this e-retail app was monolithic app, if this e-retail app was monolithic app, scaling of the app can happen on the app level. Individual functionality level, I cannot do scaling. Scaling will only happen at the app level. So if we were designing it or implemented it as as a monolithic app, entire monolithic app should be scaled, isn't it? I cannot scale it based on individual functionality, isn't it, guys? Yes. But instead of monolithic, if we had architected it as a microservice based app, do you think I can scale only payments? Yes, because one microservice number 3 or 4 is handling only payment. So only the payment microservice I will scale. Maybe rest of it I will keep it as one instance each. But only the payment I will scale, or maybe only the shopping cart and payment I will scale. Rest of it I will not scale. Are you able to make out? Yeah. Advantage here is scaling individual functionalities is possible because you have architected it as microservices. Yeah. And nowadays, you rarely have clients who don't want to use cloud, isn't it, guys? Yeah. I'm sure 99.99% of people are of our clients, governments, public sector, all of them are on cloud. And when things are on cloud, cloud means cost, right? Even one small byte here and there means cost. So don't you think so? Scaling option can allow you to have more control over which of the functionalities I want to scale and not to scale. Isn't it? Yeah. So what do you feel? Do you think microservices architecture is best suitable for a cloud kind of setup, guys? Absolutely yes, isn't it? So no wonder you can slowly make out. Yeah. As and when cloud actions have increased, there was a need to even change the architectural style for your distributed apps to take the fullest advantage of cloud, right? Only one aspect of cloud I'm using here, which is scaling. Yeah. And of course, cloud also has options for manual scaling and auto scaling and all such things. That is a different topic altogether. That does not come under the microservices perspective. So I'm not talking about it. Team, are you all with me? So are these attributes fine with all of you? Do you all agree with these attributes? Right? And now based on all these, we can move on to the other topics. Yeah. Many a times me and you might think microservices is a brand new architectural style and it provides all these advantages and all such things. But did you know that microservices as an architectural style was way back used long back when Unix systems were designed and developed, right? So the thought behind microservices is nothing new. The thought behind microservices was already used very long back when Unix operating systems were designed and developed long back. Yeah. What does this Unix use? What thought process do they use when developing their operating systems? Unix follows one thought called as do one thing and do it well. Look at this thought process of Unix. Do one thing and do it well. Yeah. So if you look at how Unix is internally designed and developed, Unix is made up of lot of components and each component has one task to do. It's not that one component has 100 things to do. There are 100 components, but each component has only one task to do. But whatever task they do, that is the only task that they have to do. So they better do it well. Yeah. So microservices architecture is based on the Unix thought, do one thing and do it well. Yeah. So think of how it has been implemented in microservice. In microservice, services are small. Why are they small? Because they address a single functionality. Because they want to follow that rule. Do one thing and do it well. Right? That is why services become very flexible and robust. And services are also self-sufficient. I want you to remember this point. Remember in one of the perspective slide earlier, we took one microservice 3 and 4, which were talking to the same database, and we ideally said this should be avoided. This is the point. As per microservices architectural style, services should be self-sufficient to do their task. If a microservice is created for payment functionality, fully it has to do it on its own without depending on any others. So services should be self-sufficient, not only in terms of the functionality, even in terms of persistence of your data. Guys, are you all with me, please? Okay, so this is the thought behind microservices. So keeping based on whatever we have discussed till now, I'm sure it is easy for us to understand the advantages and disadvantages of microservices now, right? Now, first point to talk about is the advantage, obviously. So what makes microservices attractive? Liberty. Look at the first point. Liberty to choose the right tool for the functionality or the concern. This is never ever possible when you are using a monolithic app. But this facility is available. What is the meaning? Liberty to choose the right tool for the functionality or concern. Guys, at this juncture, I want to ask you everything inside this room. Okay. Idea is, have you realized that though we are all Java developers and we've been Java developers for long, but when you are building a huge enterprise application, assume it is a monolithic app, so you have chosen Java and related technologies. But when you are building these and when you are in the development stage, have you realized that some specific functionality that we were building, we could have easily developed that using Python instead of Java? Or that could have been easily implemented using some other technology instead of Java. Have you come across something like this? It need not be yes, but I'm just asking you. Yes, right? Many a times, especially if you guys come with multiple programming knowledge background, many a times we will feel, right? Hey, this we could have done it so easily in Python. Yeah. But you know what? We can't do that in monolithic, because in a monolithic app, the architectural selections in terms of the tools and technologies you use, etc., is specific to the entire app, right? See, if I have chosen that, okay, this particular enterprise app, we are building using Spring Boot. That means the technology in the background is going to be Spring Boot. I cannot use any other technology, isn't it? Yeah. But when you are working in a microservice environment, the liberty is there. So you know what? In a microservice environment, it's rare, but this option is available. One microservice, the first microservice you can build using Python and maybe MySQL as the database. Yeah. The second microservice you can build using Java, and maybe for this you are using Oracle as the database. Yeah, Oracle as the database, and maybe some other thing you are building. Okay, maybe for this you are using PHP as the backend, and for this you are using some NoSQL database like MySQL, MongoDB or something like that. Yeah. This option is available, isn't it, guys? See, entire thing is the same app, but one microservice you can build using different technology, another microservice using different technology, and another microservice using different technology, and even the databases can be different. This liberty is there for you to choose. Yeah, such kind of apps. If you usually build a microservice where different technologies and different things are used, such kind of things are usually called as polyglot application. I'm sure you would have heard it. Polyglot. Poly means many. Polyglot means many technologies you use. Yeah. But do you think practically this is going to be a cakewalk for you guys? Practically, do you think such kind of course, liberty is there, but do you think practically this is going to be a cakewalk? May not be. Okay. So you might see that even now architects might be selecting a same technology for building all the microservices. Yeah. But option is available. If at all they want, they can at least mix and match at least two technologies or at least three technologies, if not all. Okay, because just to take the advantage of it, you know. Yeah. So there is a liberty to choose the right tool for the functionality or concern. Yeah. And obviously in a microservice, it is small, right? Because we are addressing a single concern. So if it's a small microservice that we are building, obviously it will have smaller iteration cycles. Yeah. If you are working in an agile environment, maybe one sprint or two sprints of 2 weeks each, that should be more than enough for you to come up with the technology, with that functionality, right? Because it is smaller iteration cycles. Yeah. Then third point is switching to app technologies or app alternatives is faster, isn't it? Yeah. This might not be an option in monolithic app. See, in a monolithic app, assume we are working on an enterprise application development project, which is a 9-month project, and we are already in the 6th month. In the 6th month, we realize that, one functionality we can't develop in Java at all. This functionality at present is only possible in another technology. But can we shift to an alternate technology at that 6th month, guys? No. But what do you feel about microservice? Do you think when the architectural style is microservice, this facility or switching might be possible? Absolutely, yes. Right? Because you have the liberty to choose the technology, and because everything need not be in the same technology, you can shift to an app alternative quickly and easily, isn't it? Yes. Yep. Guys, are you all with me? Okay. And improved code quality and readability. Why? Yeah. Improved code quality and readability, because think from the perspective of a developer. Should the developer working in your microservice project, do they have to know in and out of the entire code base? Not really. For example, if one or assume I have two developers working on register and login, their only concern is register and login. Their only work is to ensure that those functionalities are up and running. So that way you can use experts, you can use the people who are knowledgeable about that technology, And because these are smaller chunks of code, smaller iteration cycles, code quality and readability improves. And even from the perspective of a developer, it will be easy for them to work because they need not have glimpse of the entire code base, right? So there is improved code quality and readability. Team, are you all with me? Yes, of course, broadly they have to know what part they play in the microservices app. Yeah, but it's not that they have to know in and out of everything. Okay, next. These were the advantages, but do you think microservices architecture has only advantages and absolutely no disadvantage at all? Not really, right? Of course, they have their own share of disadvantages, but what are the disadvantages? First is complexity. Yeah. When I say complex, microservices architecture is easy if you are doing a greenfield development. When I say greenfield development, if you are lucky and you are developing the entire application from scratch and you are doing it in microservice based architecture, it's easy. But why complex? If you already have an app and now you are trying to re-architect that app, maybe it was a monolithic app earlier, and you are now re-architecting that app as a microservice based app, complexities are involved. It is not very easy to kind of de-entangle things and create multiple microservices. It's not very easy. Yeah? And now many a times we are talking about clients who are working with the same banking app. Or if I just take a banking app as an example, they might be using the same banking app which was created some 10 years ago. It's a monolithic app and it's created in yesteryear technologies. Now, if somebody asks us to re-architect it in microservice based app, it becomes difficult and complex to entangle the entire stuff and come to feasible microservices. Guys, are you all with me? Yeah, of course it is complex. It's not easy. You need to have good knowledge of several things to do a good work. Yeah. Second, the disadvantage is higher cost due to inter-service calls over the network. Yeah. Think of a monolithic app. In a monolithic app, it is intra-process communication, right? Only one app is there, right? And inside the app, there are multiple functionalities. If one functionality has to talk to another functionality, it is a inter-process method call. That's it. Yeah, no other network is involved. But in microservice, this is a separate microservice. This is a separate microservice available on the network. If this has to call some method here, or if this has to call the method here, or like this, how is it making a call? This is network, right? This is making a inter-app or inter-service network call. It is like calling any other network or URL. Yeah. So when in huge microservice where there are multiple microservices and they have to talk to each other to get a functionality up and running, there is higher cost due to inter-service calls over the network. Guys, are you all with me, please? And the last one is a very important one called as nano services. Yeah, it's an anti-pattern. I'm sure me and you as a developer, are you all aware of design patterns, guys? Are you aware of design patterns? Yes, right? Can I say design patterns are solutions to commonly occurring distributed problems at scale? Yes, right? But what is an anti-pattern? Anti-pattern is the right opposite of it. Doing something entirely wrongly, okay? Doing something which is going to affect your application, that is called as an anti-pattern. Yeah? Anti-pattern is the right opposite of design pattern. So if design pattern's job or the idea of design pattern is to improve the application and its features, anti-pattern, does the reverse. One such anti-pattern that you might get into while working with microservice is a nano service. What is a nano service? Look at this word called nano, guys. Can you tell me what do you think is the English meaning of this word called nano? Micro means small, nano means? Correct, minute, very small, isn't it? Minute. Sometimes what happens is in the enthusiasm, in the josh of doing something, I don't know, I'm just giving you an example. Have you realized this, guys? Sometimes in the enthusiasm of doing something, we overdo certain things. Have you come across? Same thing might happen in microservice. Assume you get a greenfield development for one of your big clients, and all of you are like, hey, I want to do a good job. Let us get in microservices architecture. Let us create microservices. And in the Josh, you would create multiple microservices. Let me give you an example. Let us go back to that e-retail microservice that I was talking to you about earlier. Yeah. When I was discussing about that, how many microservices did you have for reporting, guys? For reports, how many microservices did you have? Only one, right? Now compare it. There I had only one, but assume people will create like this. Let us have different microservices for different reports. Okay. So for example, I will have one microservice for, okay, I will have one microservice um, for vendor report. Yeah. I will have another microservice for customer report. I will have another microservice for product report. Okay. Product report. Or people will go overboard. Even for the vendor report or customer report or product report, instead of having these three, I will have one report for, okay, assume Flipkart runs in, or at least in India, let us say, it runs in five regions, assume. Broadly, they have divided into 5 regions. So they might have one microservice where it will show you the vendor report for North region. Another microservice which will show you vendor report for South region. And another microservice for vendor report for East region, likewise. And the same thing for customer report and product report also. Product report, I might even divide it in terms of vendors, likewise. Yeah. Are you able to make out how messy this is becoming, guys? Instead of having one report, one microservice which was handling all report, now you have multiple microservices and each one of them handling one specific thing. Yeah. See, it might be easy for you to create a microservice, but think of it. Assume if somebody asks me, give me a consolidated customer report for past 1 month. How many microservices have to talk to each other to give me one consolidated report? Guys, assume the requirement is somebody asked me to give me a consolidated report for my customers for the past month. How many microservices have to talk to each other? At least 4 to 5, right? Assuming that 5 regions are there, 5 microservices have to talk to each other and one person might combine everything and give it to you, right? But they have to talk to each other. When they talk to each other, they are doing inter-service call over the network. So again, it is a costly affair, isn't it? Yeah. So it is not very easy, there's no hard and fast rule here. There are sometimes without unknowingly we will move or we will slip into this anti-pattern kind, this nano services kind of mood. Yeah. So we have to be very careful while planning. We have to really think of lot of things before we decide, should we divide it into one microservice or not? Yeah. What are some of the things that you have to remember why you might want to divide? Is there a separate scalable requirement that I might have? Do I have to ensure that they are easily replaceable? Do I have to ensure that the changes are isolated? Based on all these attributes, you have to decide how many microservices you are going to have. Guys, are you all with me? Yeah. And it is not that just because you know how to create a microservice, you should not create a microservice. Are you all with me? Okay. So these are the 3 points which come under the category called disadvantages. Complexity and higher cost due to inter-service calls over the network, and nano service, which is a anti-pattern. Yeah. Remember all these things, please. The last slide before we close this. Yeah. After this, we'll take a break, guys. Yeah. We'll take a break. Have a look. Yeah. These are the, now that we have completed our discussions on microservices framework. Yeah. These are some of the microservices frameworks that can be used to implement microservices. Yeah. Spring Boot, Drop Wizard, Vertex, and many others. So you have Jersey, Ninja, Play, REST Express. There are many frameworks that are available to create and consume microservices. Yeah. But do you see any framework that I have highlighted here or marked in bold? Yeah. So any idea why I have marked this in bold? Spring Boot is a very popular and very capable framework that is very widely used to create and consume microservices. It's not only famous, it is also capable. Okay. So during our training also, we will be implementing and creating our microservices using Spring Boot framework. Yeah. Remember this. Team, are you all with me? People who have joined us late, you might have missed out on all the instructions that I've given you earlier. I don't know the reason why you get late. Till now, I don't really get the reason why participants are late for a training program. If you have nominated for a training program and you know that the training starts at 10 a.m. Indian Standard Time, you have to join on time or at least 5 minutes prior. Yeah, because we know network issues can happen, lot of other issues can happen. So isn't it a good practice to join the session earlier? Yeah. Please note, in case you have missed out on the initial instructions, it's very evident who has missed out on the initial instructions, please. Yeah. Once I complete a module, I will open up the forum for Q&A. Yeah. I don't want 150 members of this training program raising queries on the chat window, which I'm unable to see it. Yeah. Is this okay, all of you? Team, we will take a break now and come back. And once we come back, we will, with this, we close this module. Okay. As soon as you come back, we'll just summarize what we did. And then I will open up the forum for Q&A. And then we can take some questions from you. Yeah. So we'll take a break now and come back, guys. And then we'll resume. So before the break, we have completed the first module of our microservices training, which was an introduction to microservices. Yeah. So just to summarize what we have done in the first module, we discussed the different kinds of applications that me and you as a Java developer have been creating from earlier years. We also talked a little about what are web services. We talked about the microservice architecture. We also looked at the important attributes of microservice. We also talked about how microservices has borrowed this thought of doing one thing and doing it well from Unix. And that is the thought behind the concept of microservice. And we also talked about advantages and disadvantages of microservices. And just before closing this module, we also got a view of microservices frameworks, right? Though there are many frameworks, Spring Boot is the framework that we will be using during our training. Team, are you all with me? So going back to our agenda, Can you please look at the agenda and tell me how many modules we have completed till now, please? Correct. One module is what we have completed. Yeah. The next module to look at is Introduction to Spring Boot. Yeah. But before we do that, since I can see very clearly that many of you have missed out on the initial instructions, please note these are the mandatory prerequisites before you attend this training program. Yeah. And this training program is going to be a Java implementation training program, guys. We are not giving you some 35,000 feet above details of microservices, and we are not going to stop there. It will involve implementing and creating microservices. So this is a developer training. If you guys are not Java developers, if you don't have these mandatory prerequisites, probably only the first chapter would be useful for you, not else, not others. Yeah. Anybody here without the mandatory prerequisites of Spring Framework and Java RESTful Web Services? Yeah. This training is not for you, please. You can log off because this training is not for you. You should not be wasting 7 WebEx sessions and then realizing this training is not for you. This is a pure developer training, and we will be implementing microservices from our next few modules onwards. I want all of you to very, very carefully look at these prerequisites, especially the important note. Okay, fine. So now that we have completed our first module, I'm opening up the forum for question and answer, please. Yeah. So let me allow people to unmute themselves. Go ahead if you have any queries, any clarifications that you need on this first module, we'll do that. Yeah. Please restrict your questions to whatever we have covered till now, please. Yeah. All the others we will be covering. At present, we have covered only the first chapter, right? So whatever we have covered till now, only that we will entertain the questions. Yeah. Ramakrishna Reddy, we have still not started any implementation details about microservices, please. Please hold your question. We will be addressing your question after Wednesday. Yep. After Wednesday, we will be addressing your question. We've still not implemented microservices at all. We've still not communicated, or we have not created a microservice at all. Forget about communication. Yeah. We'll be talking about that later. Any other questions, please? You can unmute yourself and ask the questions.
Jonathan here.
Yes, please.
Samita, my question is in regards to the architecture.
Just a minute, Jonathan. I can hear echo. Others, can you be on mute, please? Others, please be on mute. Let Jonathan speak. Yes, go ahead, Jonathan.
So my question is regarding the architecture, regarding the implementation of the microservices. I wanted to know, what do you mean by event-based microservices? What is that kind of architecture? I want to understand.
Yeah, that is implementation specific decisions, Jonathan, because in Spring Boot also, there are broadly 2 architectural styles that we can build our microservices. One is a regular Spring MVC based servlet API based architecture. The second one is called as reactive programming architecture. So the event driven architecture that you're talking about is when you implement microservices by using a reactive programming approach, and that can be done by using Spring Boot Web Flux. That is another framework, and Spring Boot Web Flux is the reactive option that is available to create asynchronous back pressure capable microservices. So these are 2 broader technologies that are used to implement. So the event driven architecture that you're talking about is when we create microservices in a reactive way to build asynchronous back pressure supported microservices.
So the last question from my side. Actually, I just wanted to know the databases, each microservices architecture wise, each microservices will have their own database, or can it also have a shared database?
I think you have joined us late during the training program, isn't it, Jonathan?
I missed a bit a part in the middle, Savita. I had my
because this is something that we have already discussed. See, please note the salient feature of a microservice is it should be a single unit of work and it should be self-sufficient. Let me repeat. Every microservice should address a single concern and it should be self-sufficient to perform the tasks of that particular concern. So don't you think so architecturally also to achieve this, you need to have the functionalities and your persistence, which is nothing but your database, as one single unit of work. Yeah. So that is why the recommended is every microservice should have its own database to take care of its persistence requirements, and sharing databases amongst multiple microservice you can do, but it is highly not recommended. Yeah? Because that way it does not become a single unit of work. That way two microservices are interacting with the same database. If one if one database goes for a toss, both the microservices are affected. Or if one microservice is talking to or writing some data in the database to the same row, the same data cannot be read or updated by the other microservice. So that does not make a microservice a microservice. A microservice has to be a self-sufficient unit of functionality. So that way it's ideal to keep your databases separate. Jonathan.
Yeah, Savita, this is Mahendra. Is my voice clear?
Yes, it is clear, Mahendra.
Yeah, I just want to know about cost-wise, if you say that which one is better, like monolithic applications or microservices?
Cost in terms of network, then microservices are bad. Cost in terms of the network, monolithic is best. But here we are talking only about the disadvantage of cost that might get incurred due to inter-service calls between the microservices. Yeah, but
because here, sorry, because here in microservices, the scalability is like flexible. It's not like monolithic.
Yes, perfect. Correct. That is why we have to look at a overall holistic picture to decide whether having microservices is really going to benefit our scenario or not. Please note, guys, just because we all know microservice and microservice is in vogue, as we discussed, it's not necessary that for all the distributed app you will start using microservices. Not really.
Yes.
Remember, I told you we have to think whether microservices architecture is going to add advantage for us. Is it needed for me to break my application into multiple microservices? If I'm doing it, how am I going to do that? Which microservice am I going to create and why? Is there a scalability requirement that I might have to take care? Is there a isolation of change that I might have to take care? Based on that, you will have to decide this.
Hi Savita, can you please explain little like microservice distributed architecture? Like actually, I did not.
We have still not reached microservice at all phase. Yeah, I want you to wait until we continue with the implementation. Then you will know what do you mean by distributed architecture. Distributed architecture for now is when you distribute the functionality of your application across multiple application units is something called as distributed for now. Phase.
Yeah.
Okay, see, I want you to wait because I've still not started implementation of microservices at all. Then once I start implementing, I will also be introducing you to the several peripheral projects that might be required to manage a distributed app, like a registry service, load balancer, circuit breaker, etc. So you might get clarity about that when I do that. Okay. At present, I want you to know that distributed architecture only means distributing your functionality of your app across multiple apps. That is the distributed nature at present.
Yeah. One more thing, can you domain driven little information can you give?
No, we will not be covering domain driven architectural styles and discussions, because as I told you,
Okay.
microservices, there are two different trainings available phase. There is
Okay.
one training available from Architects Academy where they delve down deep onto architectural part of domain driven design, etc. And our training is from implementation perspective. So in implementation training program, I will not be able to cover any architectural details in depth. Yeah.
Yeah.
So
Okay.
DDD will not be covered in our training.
Yeah.
Any other questions anybody has in whatever we have covered till now, please go ahead. I have last 10 minutes to spare for any questions that you might have. I know we have covered only the first chapter, and in the first chapter, only broad introduction was covered, right? I know that you might really not have many questions unless we really go ahead and implement things. But still, if you have any doubts, I will be able to clarify, or at least I'll be able to tell you in which module we'll be covering that. Okay. So if there are no more questions coming in, I don't see any more people unmuting and asking any questions. Is it okay that we continue with our next deliverables, please? So before that, before moving on to the second module discussion, I will be sharing the MS team details. I want all of you to join the MS team. Because all the learning assets, etc., will be shared only on the MS team. Yeah. So just give me a minute. I'll be sharing these details with you guys. Yeah. Go ahead. I've shared the MS team details. I've also shared the code. Plus, I've also shared the link. In case you are unable to join the team with the code, you can join the team with the link, please. Yeah. I've created this MS team for our discussions. So go ahead and join this team, all of you. Complete this activity now, please. So as per our agenda, we have already completed the first module, which was an introduction to microservices. And just now I've also shared with you the MS team details. So you have joined. Others who have made a request, once the training is completed, I will accept all your requests, don't worry. But once the first module is completed, yeah, we can move on to the second part of the module, because first one is only an introductory to the broader concept of microservices, right? Now the second part will take you to the implementation perspective, right? So under the implementation perspective, we will be looking at the rest of the modules that we have planned. Yeah. So talking about the agenda for the implementation part of it. Yeah. Have a look at this, please. 1 minute. This is the agenda that we will be covering. Yeah. You all remember this agenda? Yeah. Now we will look at introduction to Spring Boot, and then post this, I will introduce you to Netflix OSS and Spring Cloud. Post that, we can create our microservices. And I have taken up one small scenario for our training. And slowly, apart when you just work in a microservices environment, creating microservices is just 30% of your task. But once the microservices is ready in a distributed app, you need to ensure that these two microservices are capable of talking to each other. Yeah, you might also implement several other peripheral projects to manage this entire distributed app. Yeah, under that discussion, we will be looking at registry service using Eureka as the product. We'll be talking about the client-side load balancer by using this product called Spring Cloud Load Balancer. Plus, we will also be talking about a circuit breaker pattern that is supported through Spring Cloud Circuit Breaker with Resilience 4G. Yeah. In fact, the latest versions of Spring Boot is what we are going to use to implement them. So talking about the client-side load balancer, earlier we used to use one product called Ribbon. But from the latest versions of Spring Boot, especially from 2.4 onwards, it no more supports Ribbon. So if you want to implement client-side load balancer, we have to use Spring Cloud Load Balancer. Yeah. So Ribbon was earlier part of our training, but Ribbon is no more supported in the latest version. So the alternative to Ribbon is Spring Cloud Load Balancer. Yeah. Similarly, if you want to implement circuit breaker, earlier we used to use one product from Spring Cloud called as Hystrix. Now in the latest version, Hystrix is no more supported. So in the latest versions of Spring Boot, an alternative to Hystrix as a circuit breaker is Resilience 4G. So that is what we will be covering. Yeah? There's no point covering something where it is no more supported, isn't it? Yeah. So this is what we will be covering. Guys, are you all with me? Are there any participants who are from earlier versions? You are already working in a project where they are using Spring Boot version 2.4 or lesser? Yeah. 2.4 or lesser, anybody? Yeah. See, if you guys are using, I have not removed the slides. I have slides even for Ribbon. Okay, I can even discuss about Ribbon, etc. for maybe 5-10 minutes. But for implementing, we will be using only the latest products. Is that okay, guys? Yes. So this is what we will be dealing with. Yeah. Now, I just want a count. I will be starting with this module. I have another 22 minutes now. Sorry, 12 minutes now, which I don't want to waste. But I just want to start with the first module, Introduction to Spring Boot. I just want to know from each one of you, are there anybody who's attending who does not know Spring Boot? Who's not aware of Spring Boot? Anybody? Okay, Venkatesh says I don't know. But Venkatesh, you're not even from Java, right? Venkatesh? Yeah, for you, I cannot help, Venkatesh. Ideally, you should not be attending this training. Yeah, you saw this, isn't it, Venkatesh? This is a pure implementation training. You need to be a Java developer with these mandatory prerequisites. Yeah. So you from SAP, I'm not too sure why you are there in this training program. Maybe you did not see this mandatory prerequisite clearly. This is a pure Java implementation program. So Venkatesh, this training is not for you. Yeah. Maybe the first chapter was easy for you to get an overall picture, but from now onwards, it will only be implementation. Yeah. So it might not be suitable for you at all. Others people who are Java guys. Yeah. If you are not aware of Spring Boot, I will be giving you an introduction, and during the introduction, you will get a fair idea of how Spring Boot works. Yeah. Is that okay? Great. So come, let's start off with this on Spring Boot. Yes, there are some remarks coming. Some people learn Spring Boot without learning Spring Framework. Yeah, yeah, that is the new style that's proposed nowadays. But without knowing the basics of what is inversion of control, what is dependency injection, and why Spring was used, understanding and appreciating Spring Boot becomes tough. Okay. But anyway, let me not get into that. If you are aware of Spring Boot, fine. But I am introducing Spring Boot to those people who are new to it. Is that okay, all of you? People who are brand new to Spring Boot. This is a very important module for you to analyze. Okay. So come, let me introduce you to what I'm going to cover under the Spring Boot section. People who have already undergone the Spring Boot training, or people who have already, you guys are aware of Spring Boot, this will be a repetition chapter for you. Okay. So these are the objectives that we will try to cover under the Spring Boot. Please note, guys, Spring Boot itself we have as a separate 5-day training program. Yeah, but our intention during this training program is not to cover Spring Boot entirely. We are only giving you a broader introduction to Spring Boot so that you are capable of creating a Spring Boot based application, because Spring Boot is the framework that we are going to use to implement our microservices. So every microservice will be nothing but a Spring Boot app. Yeah. So if you want to create a microservice, you need to know Spring Boot. That is why we are covering this introductory module. Yeah. So at least let me cover few introductory things, and tomorrow we can spend our time in covering the rest of the topics. Yeah. So come, let's look at what objectives we are going to cover under this second module, which is on Spring Boot. Yeah. These are the objectives. We will look at what is Spring Boot. We will talk about the features of Spring Boot. We will also talk about one very important concept in Spring Boot called Spring Boot starter modules. Then based on all this understanding, we will see how to create and execute a Spring Boot app. And apart from regular dependencies of Spring Boot, what are some of the additional modules or additional dependencies that you could use? What are some useful features that are provided by these additional modules? That is what we will talk about. Yeah. Please note, this is the same discussion that we usually have in a typical Spring Boot training program. So people who have already undergone this training, this will be a repetition for you. The second chapter will be a repetition for you. But please bear with us, because there are many participants who join this training without this knowledge. Yeah. So this training, this module is for them. Yeah. Have a look. What is Spring Boot? People who have worked with the Spring framework, you'll realize that Spring is a framework that can allow us to easily create enterprise applications based on Java, right? Spring framework provides us the features of inversion of control and dependency injection and many others, where the entire life cycle of a bean is managed by your container. So creating your bean, managing the dependencies, managing the relationship between the beans, injecting the dependencies that each of your beans need, all that will be managed by the Spring framework through its container, right? That we are already aware. So me and you might have already been using Spring framework to create our enterprise applications. So why should we use Spring Boot? Have a look. Spring Boot framework makes it easy for us to create a standalone production grade Spring app, which you can just easily and quickly run. So if you want, the idea is, if you want to easily and quickly be able to create your Spring based application, then the choice for us is to use Spring Boot. So Spring Boot makes it easy for us to create such standalone app. How does it allow me to create a standalone app? Typically in Spring, when we create a Spring based MVC app, web app, after creating an app, we usually used to deploy that app on an external app server like Tomcat or whatever, right? But you know what? In Spring Boot, Spring Boot makes it easier for us to quickly and easily create a standalone app. How does it make your app standalone? It makes your app standalone by providing a inbuilt embedded app server. So by default in Spring Boot, when you create an app, it will by default provide you an embedded Tomcat as your app server. So that once you create your app, automatically you can easily run your app without even being dependent on external app server. Yeah. So idea is, if at all you want to create a standalone app, Spring Boot is the best choice for it. Kind of link it to our microservice, guys. Does microservice expect your apps to be standalone apps addressing a single concern on its own? Does microservice expect you to create apps which are single apps addressing all the concern on its own? Yes, right? So Spring Boot is the best option for you to create microservices. Yeah. So Spring Boot makes it easy to create such standalone apps. And actually, Spring Boot is an opinionated framework. When I say it's an opinionated framework, what Spring Boot can do is, depending on the kind of application you're planning to create, Spring Boot is able to make reasonable guess as to what are some of the Spring related dependencies you might require, what are some of the third party libraries you might require, and it will automatically provide all these basic configuration and basic beans on your class path so that you and me as a developer can get started with minimum fuss. That is what Spring Boot does. Yeah. And when we use Spring Boot and when we create Spring based application, Spring Boot applications need very little Spring configuration. You need not sit and do any Spring related configuration. All the basic Spring related configuration will be handled internally by Spring Boot. Yeah. So you need not sit and do any basic configuration. We have to only concentrate on building our business logic and implementing our functionality. Rest of the basic Spring related configuration will be automatically handled by Spring Boot. Yeah. So Spring Boot is a framework from the team at Pivotal. You might have heard about this company called Pivotal Software. In fact, Spring Boot is a framework which was developed by the team at Pivotal. At present, Pivotal Software is taken over by VMware. So at present, it's a VMware company. So Spring Boot is a framework which was designed and developed by the team at Pivotal. And the whole idea of coming up with this Spring Boot framework is to simplify the entire development and bootstrapping of a new Spring application. So if your intention was to create a Spring application quickly and easily, answer for that is to use Spring Boot framework. Yeah, as we discussed in the previous slide, the Spring Boot framework takes an opinionated approach. So based on the kind of application you want to create, it automatically provides and takes care of this basic configuration, and it will automatically take care of defining the boilerplate code in several places. They on writing good business logic to handle our requirements. Yeah. And look at the last one. That's a very important point to note. Yeah. In Spring Boot, the initial goal of Spring Boot is to embrace a XML-free development experience. This is very important point because in Spring Boot framework, no need to write even one line of XML-based configuration for Spring. Spring related, no need of writing any XML-based configuration. Yeah, not even web.xml. Guys, are you getting a little shaky here? Me and you as a developer, especially developing web apps, we are so used to having that web.xml file, isn't it, guys? Yeah, but you know what? Look at the last line. Spring Boot proposes a XML-free development experience. So when we start using Spring Boot, no need of writing even one line of XML configuration for Spring, not even web.xml. Remember this. Are you all with me? So just remember these initial details of Spring Boot. Tomorrow when we assemble, we will continue our discussions from Spring Boot features. Okay. And from here we can continue. Is that okay, guys? Yes. And once I finish the Spring Boot introductory module, in case you guys want to learn more about Spring Boot, I'm ready to even share those recordings with you on the MS team. Whenever you have time, you can go through. But during our training, because we are focusing on microservices, I will restrict my discussions only to the basics of Spring Boot that might be necessary for you to know for microservices. Is that okay, all of you? Yes. So that's it from me today. We will all meet tomorrow and we'll continue from this slide, please. Yeah. So we're still in the second module. We'll continue from here and then we can move forward.